I'm going to talk to you today about creating without limits. And I want you to understand that this is something that I'm passionate about, and I'm going to be completely transparent with you. It's something that has become, that's where a laugh comes. It's something that has become so ingrained in what I do that this has now become my job. So my job is essentially creating without limits. Okay, that didn't land. So, a lot of my memories revolve around creating things and making things. Anybody here have a memory, the favorite memory of making something when you were a kid? Yeah, right? Okay, so for me, one of the things that I remember was my grandparents had come back from a trip and they brought me a model of a 1909 Renault, and it was an ugly car, but it was a really cool model. And I was like 5 or 6, and I just started building it. And I got finished, and my mother said, "How did you do that? The instructions are in French." And I said, "I don't know, it just looked like the pieces needed to go together." To me, the fun was making it. My mother also had a cousin who, to me, was like the coolest thing since Hot Wheels cars. This was an adult who built models like an adult. He took the time to paint them and detail them, and the eyeballs on the pilots and the dials on the instrument panels. And the thing that I like the best is when he would show me how he did those things. And I was hooked. I mean, I just was amazed at how you could take this pile of plastic and turn it into something that represented real life. So that really was kind of formative for me. Found out later on that he had been a World War II veteran in the Pacific Theater, and so he had a first-hand knowledge of these planes that he built. And so while he was in the city, he lived in New York, and as you can tell, I'm from New York. His work was displayed on the USS Intrepid Aircraft Carrier Air Space Museum, and I just thought that was neat, that he was somebody who had a passion for creating and used that passion to share with others. And again, I think that his teaching me how to do things pushed me beyond a limit. Okay, so every time I would make something, whether it was planes and models in this case, or anything, when I would exceed a limit of my capability, that was the joy. And that was what really got me on the path to wanting to do that for a career. It sounds like I want to make things. That's what I'm going to do. So getting back to the point of my talk, which is creating without limits. Okay, we have to first look at how creativity and how creating has changed through the ages. So let's take the really simple concept of cutting. Okay, that's something that's kind of important to making things, whether you're cutting a tree to make lumber, or you're cutting the lumber to make something that doesn't look like lumber anymore, or whatever, those pieces have to fit together. So cutting is kind of a big deal. So about 2.8 million years ago, there's evidence that says those old cavemen, they used axes and hammers, and they also needed things to cut with. And most likely it was cutting their food, but it was still something that they had to transform from one to another. Somebody had the great idea of putting a handle out of bone or wood on these stone things, so now it was much more user-friendly. In the 1600s, they started using what's called a pit saw. So they would take a big pit, drop a tree over it, and these guys would stand on one side, the higher end, and one guy would get in the pit, and they would saw logs. That's how they would do that before sawmills. So I'm really thinking that this is where the expression, "this is the pits," came from, because you didn't want to be that guy in the pit, but I have absolutely no proof that that is where that saying comes from, but I'm sticking to it. Anyway, so in 1777, a guy named Samuel got a patent. He got the first patent on a circular saw blade. But it wasn't until 1813 when Tabitha Babbitt turned that circular saw into something representing the table saw that we now know. She was a shaker, so she could not patent that design, and a couple of years later, some people picked up that information and went ahead and patented it. So why am I talking about all this stuff? You think about the way cutting, that simple operation that's involved in so many things that we make, evolved because of a technological limit that was exceeded. Now we have CNC machines. CNC stands for computer numerical control. That actually was developed in the 1940s, believe it or not, and the first machines were punch tape operated. So they would basically take a motor with a cutter head on it and move it from one point to another because of the computer-controlled information. Now, you can't come in contact with just about any product that's mass-produced that doesn't have some type of CNC operation involved in its making. So again, the possibilities of what could be created were achieved because limits were exceeded, all right? So I'll stop and just tell you real quick. I went to college in Philadelphia. It was called the Philadelphia College of Art, graduated in 1982. And back then, there were no such things as desktop computers. I'm really aging myself. And CAD stations were just starting to come into fruition. So the engineers had them. The wood guys did not have the luxury. So when we wanted to draw a chair, we would take a piece of paper, tape it up on the wall, and your limit was the size of the paper, and sometimes you ran off the paper onto the wall. Teachers weren't that thrilled about it, but you had to do what you had to do. And what you would do is you draw a front view, side view, top view, and then hopefully when you started cutting wood, all those views would mesh and it would be great and you'd have a perfect thing. And then you would also see your limits as to whether or not you could really draw that by hand and get all those pieces of geometry to line up. When computers and CAD stations became a thing, you now could take a drawing and build every single part. And that's really how things are manufactured today. I mean, I work with a lot of furniture companies, and there's a lot of furniture people in here, I'm sure. Most everything is designed in 3D now. And so that three-dimensional geometry helps to show the parts and helps to show how that thing should be built. But it also gives you the side benefit. Now that you've got this three-dimensional thing, you can do other stuff with it. In the picture you're seeing there, you can take that geometry, and you know all this, you can apply light to it, and texture, and patterns, and make it look like the real thing. So that 3D visualization has also pushed our limit. Okay, so our limits are constantly being exceeded because of the technological advances that we have. A lot of you are familiar with 3D printing. So I'm not going to go into the details. I was talking to some guys before. If you want to be bored to death about 3D printing, see me after this. But the bottom line is, what drives these kinds of machines is that digital geometry that I was just talking about. So you draw something in 3D, and now you can hold it in your hand in a matter of hours. Talk about blowing past a limit, right? You can start thinking about things and go right to your computer if you're fluent enough and start drawing something and hold it in your hand in no time. Whether it's a piece of furniture or an electronic component or, and when I say piece of furniture, I'm talking scale models. My machines aren't large enough to actually build pieces of furniture, but I've been asked to do that. But whatever it is, this that you're looking at right here is it's an award for, believe it or not, there is a thing called the American Beatbox Championship, and American Beatbox is the company that I worked for last year and created this award, and now I'm working again for them this year on their revised awards. And essentially, this was created on the computer, 3D printed, gold leafed. You talk about a lot of work. But the thing is, whatever you can come up with, you can now have. And that is limit breaking, okay? So I'm working with a gentleman right now who's an inventor, and this guy, he said it's not an official title, but he's a microelectronics engineer. So the things that he designs are tiny, but they're used in useful operations. He wanted to build a device that, all I can really say about it because it's proprietary, it's a counter. But if you look at this picture that shows the actual parts there, there's a ruler, and those are 32nds of an inch. So the pieces between those discs are about 2 millimeters across. The photograph on the bottom left is through a microscope looking at those pieces, and those tiny little layer lines are about 20 microns, 25 microns. Microns, like, you know, that's about the size of your hair. The image above is how that geometry started off as a CAD model. This guy was told, you can't make something that small and have it work on a 3D printer. And he went around to people, and they kind of reinforced that. We hooked up, and he asked me about this, and I said, wow, that's really cool. I'd love to try that. I have a machine that I think could do that kind of thing. And this is in comparison to a dime, showing you how small this device is. The big photo of the gear, that gear fits inside that device. So you see the resolution of those gear teeth? Who says we can't do it? Well, we did it, man. And the thing is, where is this going to be next? What's the next thing that creativity beyond limits is going to take us to? You know, where are we now? We're, you know, 3D printing arms. We're 3D printing cells. So what I would just challenge you to think about is this technology is available. I mean, you could drive by somebody's house and not realize that just some guy has a garage full of 3D printers, you know? And that means manufacturing can be happening everywhere. And so that's what I want to challenge you with. Just what is next? What's going to happen next in this world that we live in as far as 3D printing, as far as just creating beyond limits goes? Thank you.